In today's lecture, we are going to see the operation of DC generator. So this lecture is divided into three parts. In the first part, we'll understand the basic concept of force acting on the conductor. And second part, EMF induced in an armature conductor. Third part, how do we convert that induced EMF from AC to DC using commutator. Let's look at the first part. Any DC generator works on same principle, which can be analyzed and understood easily by using a simple loop generator. Means I'm taking one loop. In actual practical generator, there are many loops, there are many turns rather, but for simplicity I'm considering only one loop, hence it is called as simple loop generator. We have two poles, north pole, south pole. Flux flows from north pole to south pole. We have one turn, that is two conductors. Red conductor is connected to red slip ring. This black conductor is permanently connected to this black slip ring. And there are brushes connected, two brushes connected to these two slip rings. These brushes will be connected to the load for further uses of EMF generator. Let's look at the two-dimensional view of this. Just say poles and conductors. Flux flows from north to south. This is the flux direction and this is the flux axis. These two are conductors. Now they are rotated because we are giving mechanical energy, so they are rotating. Now let's look at different instants of rotation. At one instant, let's take a starting instant at this position. Force acting on this conductor, because it is rotating circular, it is taken these rotations. Force acting on this conductor is tangential. So at this instant, tangent is, so there is a force. On this conductor, there is a force acting on this conductor. So flux is this way, for perpendicular force is perpendicular. So complete this F will participate in EMF induction because these two are perpendicular. Let's look at another instant. After it is taken 45 degrees rotation, this is 0 degree rotation. Let's take another instant after taking 45 degrees rotation. So it is taken rotation of 45 degrees. Now here also force is acting this way, F. There is a force. This force can be written in as two forces. One is y-axis force, another one is x-axis force. Out of these two forces, y-axis force is the one which is perpendicular to the field. So y-axis force is responsible for EMF induction, not x-axis force, not tangential force. Now, what is the relation between F and Fy? Because we know this angle is theta. Fy is equal to F cos theta. Means after 45 degrees rotation, y-axis force is reduced a bit from this relation. For further rotation of 45 degrees, means total 90 degrees rotation. Now force acting is tangential this way, In the same way, let's take x-axis force. This is F, and which is equal to x-axis force. There is no y-axis force at this instant. So here Fy is 0. From this relation also you can say, if theta is 90 degrees, cos 90 is 0. So Fy is 0. So this relation is always valid. Now for further rotation of 45 degrees, now force will be acting downwards, hence Fy gets negative. Again, from this relation you can say the same. Now the same relation is valid here also. So this is the conclusion of this part, that is Fy is equal to F cos theta. The force which is responsible for EMF induction is getting changed in this fashion. Now let's look at the second part, that is EMF generation. We know this form: poles, conductors, slip rings, brushes. Brushes are fed to a load. You follow the terminology carefully. This red conductor is always in connection with this slip ring. This black conductor is always in connection with this slip ring. And this brush 1 is always in connection with slip ring A. Brush 2 is always in connection with slip ring B. And load connections. This is very important. Now I am rotating the rotor in counterclockwise direction. This is the direction of rotation. So the force acting on this conductor is upward, and the force acting on this conductor is downward. If you apply Fleming's right hand rule, force is upward, flux is this way, current is inward, cross. So here current is cross, and conversely here current is dot, cross and dot, which means current is coming out of this conductor and going into this slip ring to the brush and to this way, and will flow, will go to this conductor, yes, cross, again will come out, will go to this brush, this slip ring, and load this way. So if you draw the path, current is coming out, will go here, and again here, 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 here. So this is the current direction. So current in the load is from B to A. Now we know force acting at this instant is F, and Fy is equal to F, means the force is maximum only at this instant, and for this maximum here but downwards, here it is upward. As force is maximum, EMF induced will be maximum here. At this rotation, at this instant, EMF induced is maximum. As it is taking rotation, we have seen Fy reduces in cosine form, so EMF induced also reduces in cosine form, hence current also reduces in cosine form. So you can see the same rotation, current magnitude and EMF. see while it is rotating. You can see the same here. Force Fy is reduced, hence EMF is reduced, hence current magnitude also reduces. Next, see the pattern. Now it has become 0 because y-axis force is 0, EMF induced is 0, current also 0. Now further rotation. Now this has converted to dot. Previously it was cross, now it is dot, because till in this region force is acting upward, but here y-axis force is acting downward. Force direction has changed, hence EMF direction also has changed to dot, means EMF has gone negative. Current also changed its direction. So now current is flowing from A to B. Because this red is always in connection with this slip ring. So here current is coming out, which will enter into this, and further it will travel. This black slip ring is connected to this black conductor, so current will go in. Yes. Now further, maximum force downward, maximum induced EMF, maximum current. So if you notice, current flowing through the load is AC, not DC. Further, you can see in complete form, in full cycle, you can observe the current direction, dot, cross, everything. Current direction is changing here. This direction, positive, negative, positive, negative. Means AC current is flowing through the load, though it is a DC generator, if we use slip rings. So let's do something to convert this AC to DC. So for that, I'll use split rings, means I'm splitting the ring, I'm splitting the slip ring into two parts, two halves. Okay. So in between these two, there is some thin insulation is there, mica insulation is there. So these two are electrically separated. So this half are electrically separated, and as usual this red conductor is always in connection with this red part, this black slip ring is always in connection with this black part. Now the same in 2D form, this is always in connection with this is always in connection with this. Now let's look at the rotation. Now the thing to be noticed is this segment, this part, this red part is now in contact with brush 1. This black part is in contact with brush 2. Now if you notice, this red part is in contact with brush 2, Unlike in case of slip rings. In case of slip ring type, what we had is red part was always in connection with brush 1. But here, this red part is now in connection with brush 2, and this black part is now in connection with brush 1. So here, like previous case, current direction has changed from cross to dot. So current is coming out, which is fed to this red part. Now red part is in connection with brush 2, so current flows this way, which is same as before. Observe the current directions. Now further, cross means current is going in from here. For a full cycle, you notice current directions. Current is always from this side to this side, this way. But magnitude is changing. So basically we rectified AC to DC by splitting the slip ring. So this is called as split ring, or we'll call it as commutator. So by using commutator, we convert AC to DC. So the conclusion is EMF induced in a DC generator is AC. If we connect slip rings, the output is also AC. But if we replace slip rings by split rings, that is commutator, we'll get output is DC, though generated voltage is AC. Thanks for watching. If you want us to discuss any topic in electrical engineering, please write to us through comment section below. And please subscribe to our channel for more updates. Thank you.